All right, chapter 6.6 in your last week for chapter 6. You have a test this Friday. Your pre-test goes up tomorrow to close on Friday. But this lesson's focus here is on the skills of multiplying and dividing more complex radicals. Just be sure to focus on the logic behind the steps and understand why the process works, and that will give you more ability to manipulate difficult numbers. Remember, you are going to be moving into higher level math. Actually, you're already in higher level math, but you're going to be moving into higher and higher levels, and you need to kind of understand how to use rules to your advantage in order to be effective. Let me fix this thing so it's not as dizzyfying as it is. Give me 1 second. Okay, so you should know most of the rules necessary. I will discuss the rules as we look at the examples, but again, I'm not going to take part of your lesson time explaining the rules that, again, we kind of covered in all the other stuff. I'm just going to explain it as we go. And again, if you have questions, email me and, we'll discuss it. But that's usually how things work in real life, and especially in math. Ask about what you don't know, get an answer, and make sure you don't need to ask twice. And if you have to ask twice, make sure you don't have to ask 3 times. But at some point, try to make sure you know what's going on. That's the general goal. Simplify using the shown sequence of steps. I know I'm going to mess this up, but again, if you're working on a problem on a computer and you're not sure exactly what steps to show, but you have the process down, yes, you'll have to kind of miss one, but remember, you can always hit similar problem and get those points back. But usually what I would do is, if there's a bunch of boxes, I just put a letter in each box, get it wrong, and then make sure that whatever they're showing match it, or that I know what the boxes want me to show if I'm lost. Now, once you have those notes, you can use those on your, on your quizzes and tests. I'm sure some of you are using, but again, just make sure that you understand what the setup is first before you start getting frustrated and getting upset with me. But anyway, what we have rules wise is we cannot put a third root with a sixth root because this is not legitimate. So what we can do though is turn this into 81. Sorry here. Should have prepared 81 to the 1/3 times 243 to the 1/6. Now, when it comes to this, you have to make sure you understand how to convert. You also cannot put these, like you would add the exponents if our bases were the same, but of course they're not. And so what we have to do is identify a number and see if 81 can be broken down. Well, 81 from what I know of is 3, 9, 27, 81. That's 3 to the 4th. 243 would be 81. That would be, I think that's 243. So 5 of them. So what we're looking at here is, in terms of converting 81 to the 1/3, you're looking at 81 to the 1/3 is the same as, I'm sorry, I'm just messing this all up. 81 to the 1/3 is the same as 3 to the 4th to the 1/3, which, following our rules of multiplication, becomes 3 to the 4/3. Same thing for 243. 243 to the 1/6 is the same as 3 to the 5th, because that's what 243 is, to the 1/6, which is the same as 3 to the, again, multiply 5/6. So I'm pretty sure you have to bring that as your second one, but anyway, it ends up being 3 to the 4/3 times 3 to the 5/6, which you then must, again, now that you have the same base, you can add them and then go from there. So 4/3 and 5/6, that would be 8/3 or 8/6, because remember, notice 3 and 6 have pretty similar roots. So if I double that, that'll be 8/3 plus 5. I'm sorry, 8/6 plus 5/6, which would be 3 to the 13/6. And notice it does want a rational exponent, which means that they do want it in that form. Just, again, make sure you understand those steps. These steps, yes, they're being put together for this problem. Yes, the problems are repetitive, but the steps you're doing are important. Being able to convert 81 to the 1/3 into 3 to the 4/3 is important, but understanding to create the number based off of breaking it down to a 3, substituting that 3 to the 4th, and then multiplying, that's a very important step for you to kind of get down. So again, just make sure you're trying to figure all that out. Another one here. Again, what we're going to do here is, again, you cannot roots are very, I guess the word is malleable, but the roots aren't malleable, but the word I'm thinking about is malleable, which means that you can shape them, you can manipulate them a lot. Roots themselves are not malleable, but the fractional form is malleable. This actually ends up being b to the 1/7, and wouldn't we subtract b to the 1/9? Or how do we do this? It's b to the 1/7. Again, I'm not sure how this works on the computer, but you can check that out. B to the 1/7 over b to the 1/9. I don't think you need to write that. I think we go straight to b to the 1/7 minus 1/9. But again, that turns into that fraction, which means we then take top minus bottom. 1/7 minus 1/9. Another way to multiply fractions, as you'll see, especially whenever they can't be same denominator, is to multiply across the bottom this way and that way. So I did 9 times 7, 9 times 1, copy the sign, 9 times 7, it'd be 2 over 63. And the radical form, that's not a radical, that's the exponent there. So what we're looking at here is the 63rd root of b to the 2nd. Again, I believe those are your 3 boxes that you will do. I tried to check it out before, but there's so many problems that I've given you that make you show work that I don't remember exactly which ones want what and where I skipped and all the other stuff. But again, if your notes don't match and you see 4 boxes, of course you'll add that. But just, again, easiest way to do this thing is to just miss the problem, see what it's looking for, and make sure you learn the process. The point of math is not always in finishing the problem, finishing the homework. It's about understanding the work, so just make sure you're ready for that. Here, you're going to put r to the 1/3. Again, they want this in radical form. But you can't put a 3rd root with a 7th root because, again, this is not malleable. But the exponential form is malleable. So that's r to the 1/3 plus 1/7. Actually, I don't think you need to write that, but again, I don't know what it's asking for. I'm sorry. And because of the method I showed you up here, you can actually do fractions in your head, which is why I showed it to you, because it makes fractions, simple fractions at least, easier to deal with. Because here's what I do. 3 times 7 is 21. 7 plus 3 is 10. Again, 21, 7 plus whatever that is, 3 makes 10, and then in the end you end up with the 21st root of r to the 10th, and that is your radical form. Again, I don't think you need this step. I think it goes from here to there. But again, just miss the problem real quick and see what happens. The key thing again is that you understand how to do the steps. As long as you understand how to do the steps and truly understand them, then you'll be fine whenever that pops up or whenever something similar pops up. It is amazing how whenever you actually work for understanding, how whenever you're taking the ACT or SAT, something pops up and your brain can automatically kind of see what it needs to because you're under pressure. So you'll remember it. It's just, you know, it won't be right in the forefront of your memory at all times. Again, this one here, you're going to, first off, you want to combine these roots because there's 2 roots. We need to put them down to 1. So what we're going to do is again, change forms. We're going to turn this to x to the 10/7, y to the 16/7, x to the 19/3, and y to the 13/3. We are then going to put our x's together to put x to the 10/7 plus 19/3 and y to the 16/7 plus 13/3. Notice how big these numbers are, so it'll be kind of tough. Let me get a calculator or something here. But again, I can still kind of do that where I do 7 times 3 being 21, so x to the something over 21, that's 30, and that's 70 plus 63, which is 133, so 133 plus 30 should be 163. I don't know. Good for me. And then y should be 48 and 91. 48 and 91 make 139 over 21 maybe, I don't know. Good for me again. And then in the end they want radical form. Again, whenever you're doing these, make sure you're paying attention to what form it wants. It wants radical form, so again, it wants 1 full part. Now, here's my advice for you. If you're working this out and you get a fraction that can be simplified, I would not simplify it, because once you change the root number, you can no longer combine them into one root. Again, this problem, combining the roots, you don't want a 21 here and a 7 over here because you can't put them both into the same root. And so on this problem, really only is the one where you will leave it as 21, because that way you can actually put everything where it's supposed to be. X to the 163rd, y to the 139th. But do not forget that that can be simplified, because this means you're dividing by 21. It goes in 7 times. And let's see, 7 times 21 takes me up to 147 minus 163, which is 16 left over. So we'll get to that. I'll deal with the other one. I'll deal with this first. 139 divided by 21 is 6 times the 21st root of x to the, what I say, of course I didn't get that. 7 times 21 minus 163, which is 16 left over here, and 139, I'm sorry, what was that? 21 times 6 minus whatever I had, which is 139, which is 13 left over. But again, notice it's pretty much similar work to what we just did in 6.5, no, 6.6. I really don't know anymore which section it was. But I just know the last section we worked on, we were dealing with this a lot and making sure we knew how to do that, but that is why. The key thing to know is, again, 1, 2, 3, 4, 5 boxes. Make sure you understand the processes. Make sure you know where those numbers came from, and also make sure you can know that you can assume these are positive variables. There's no need for absolute values on this. But again, this is what's going to make it tough at the end of the week when you take your test, is that if you don't practice this problem, you will not get this problem right. I don't think that there's any other way around that. So just make sure you're ready for that. And again, make sure you're communicating with me. It does not frustrate me to help you learn it, as long as you've done your part. It frustrates me whenever you try to push like 5 weeks worth of work or 2 weeks worth of work and get it all done within 2 days. So as long as you're doing what you're supposed to do on a regular basis, communicating with me is not an issue. Now, another rule in terms of radicals is that you cannot put radicals together in addition unless their roots are the same. Again, I think I said in class, 2x plus 4x makes 6x. So 2 root 2 plus 4 root 2, same way, makes 6 root 2. But you cannot put different radicals together. It would be like having an x and a y. So what we would do here in this situation is try to see if we can break this down. And 63 is divisible by 9. Remember the perfect number for squares. 9 comes out as a 3, so this is 3 root 7. So I'm going to simplify that. 112, I think 4 goes in, because remember the trick for 4 is that the last 2 digits can divide, and it does. So that's 4 times, let's see, 4 goes into 11 twice with 3 left over. 4 goes into 32 28 times. 28 is 4 times 7. So this comes out as a 2, this comes out as a 2, so that would be 2, 4, root 7. And now notice once we simplify it, we can actually get the answer that we're looking for. So again, that process is also important, because you never know when you have to deal with radicals. There are third root problems, fourth root problems. I understand the TI-30X, the Texas Instruments multi-view calculator would simplify that for you. But again, there's certain things at some point you won't be able to take shortcuts on. So be sure to practice it, because again, if you plan on moving forward up to the pre-calculus level, which everyone who's taking this class is on the pre-calculus thing where you have to actually pass pre-calculus to graduate, just again, make sure you learn it, because you have to know the process. If you don't know the process, there's no sneaking out of your math track. Simplify again. Here we go. 8 is 4 times 2, which means a 2 comes out. Now pay attention to this. A 2 comes out meaning a 4, which means that makes it 8. But you also have an a squared, which means it'll be an a. Again, assuming positive variables means we don't have to change that. So again, 2 divided by 2, because remember there's an invisible 2, which means the only thing left over this is the 2, because the a is gone. 72 is 9 times 8. And then 4 times 2, this comes out as a 3, this comes out as a 2. 2 times 3 is 6, 6 times 4 is 24. Again, A is going to come out again, and 2 is what's left on the inside. 32 is 4 times 8, which is 4 times 2. 2 make 4. 4 times 3 make 12. Again, A squared turns into A. 2 stays. Because all 3 of these have 2's, we have the potential to put them together. And because all of these have A's on them, we can put them together. If this was a regular 8, it would not be able to combine with something with an 8, going back to those old rules. So, negative 24 minus 12 is negative 36. Negative 36 combined with a positive 8. 36 minus 8, I believe, is 28. I forgot my A. So again, negative 28 A root 2. So let me make sure negative 24 minus 12 plus 8 is negative 28. Yep. Sorry for my ugly numbers. But that would be your stopping point. Just again, make sure you're learning the rules. Again, at this point, you're at the level of math where you either care enough to try to learn them or you don't care, and that's a very dangerous place to be because, again, these problems are going to get tougher and tougher every year, and there eventually is no way out. Third root, 8 times the third root of 24, third root of 81. I remember the third root numbers as 8, 27, 125. And remember, that's 2 to the third, 3 to the third, 5 to the third. That's where I get my list from. This is 8 times 3, which again, 8 is a basic 2. 2 times 8 makes 16. Third root of 3. I remember from doing my perfect numbers that 27 times 3 is 81. So this is also 27 times 3. Again, 27 as a perfect number of third root is a 3, which makes this 3. Third root of 3. Again, the endings are exactly the same, which means now I can put 16 plus 3 to make 19. Third root of 3. Yes, I'm moving a little fast, but again, that's because a lot of those rules that I covered have already been taught. They should have already been practiced. And again, if not, just make sure you're going back and either revisiting those rules or, as I said, send me an email. I'll be glad to discuss it with you, but I'm not going to take time in a video where I'm trying to get out of your way so you can work in terms of revisiting things that I've already taught. That is why they're in video form, because you can always go back and rewatch videos. Remember, again, you need to apply all of your knowledge. That's why I'm saying that you might want to make sure you're figuring this out, because if you can figure out what steps are possible, eventually learn to see more. What I mean by that, I don't know if anybody plays chess, but when you start playing chess, you typically lose because you can only see one move in front of you, and the person next across from you can see 10 moves in front of them. And what happens is they have the advantage. But the more you play, the more you learn how to move your pieces. And the more you play the game in general, you learn to say, well, if I go here, then they'll go here, and I can go there, etc. Same thing in math. The more you learn the rules, the more you learn to kind of work through it and practice it, you start to see where that step will, or you'll start to see what that step will look like. And then you can visualize what the next step might do. And what that will do for you is, if there are 3 different options, you can at least take 2 steps in all 3 of those different options and see which options aren't the best to take. But again, it does take work to get to that point. It will take time. Math is not, something you can just learn by saying, I want to be good at it, and all of a sudden you're good at it, or have somebody tell you that you're, special because they were good at math, and it doesn't work like that. You have to earn your math experience. So just make sure, again, you email me if you have a problem, but make sure you show me your attempt at it so I can actually help you, because again, the only thing I'm going to say to you if you ask for help is show me your work on it so I can find out what you did wrong. And you would save yourself 5 minutes of time or more with me sending you what I just told you I'm going to send you, which is show me your try, show me your attempt. But other than that, like I said, good luck on this, and let me know if I can help you out.